Hello, my dear friends. Welcome to the Insightful Vision, where curiosity gets cozy and science takes the scenic route to wonder. Tonight, our quiet journey drifts toward one of the eeriest and most unsettling puzzles we've ever stumbled across. Not just as scientists, but as a species sitting together under the stars. It's called the Great Filter. If you've never heard of it, don't worry. The name sounds more like something you pick up for your coffee machine than a theory about the survival of civilizations. But once you understand it, you might find yourself staring at the night sky a little differently. The filter is an idea that tries to explain why we look out into the vast universe, see countless suns and planets, and yet hear nothing back. No signals, no neighbors, no busy chatter across the stars, just silence. And that silence might mean something rather troubling about our own chances of making it very far into the future. Before we wander too far into that thought, let me pause and ask you something. Where are you listening from tonight? Are you tucked into bed in the quiet of your room? Maybe lying on a couch with headphones while the city outside hums along? Are you perhaps under the real night sky, hearing crickets or distant traffic while you listen to this story? Each of us arrives at this moment in our own setting, but all of us share the same universe stretched above us. I think that's kind of comforting. So wherever you are, thank you for being here. And if you find that this little exploration is soothing or makes you curious, I'd be very grateful if you gave the video a like or subscribed. It helps this calm corner reach more people who might need a gentle pause, and maybe tonight, a gentle confrontation with one of the universe's biggest questions. Now then, the Great Filter. What does it mean, and why should it matter to us? The story starts with a very simple question, first asked by the physicist Enrico Fermi during a casual lunch in 1950. Where is everybody? The question wasn't about lunch guests, or why nobody showed up to his birthday party. It was about aliens, intelligent civilizations that, statistically speaking, should be out there given the number of stars and planets in the galaxy. Fermi pointed out that even if life is rare, the sheer scale of the cosmos suggests that some civilization should have emerged and spread across the galaxy long before us. If you run the numbers, billions of stars, billions of chances, billions of planets orbiting in just the right way for life to form, surely someone somewhere should have built the technology to travel, explore, or at the very least send a signal by now. And yet, we see none of it, nothing but silence. The Great Filter is one way of answering that question. Maybe the reason we don't see anyone out there is because life rarely makes it past certain hurdles. These hurdles are the filters, steps in evolution or technology that are so difficult almost nobody gets through them. Civilizations might rise for a time, but then collapse before they can spread far enough to be noticed. The filter could be behind us in the form of an impossibly rare step, like the origin of life itself, or the leap from single cells to complex creatures. If those steps were nearly impossible, maybe we've already passed through the filter, and we're extraordinarily lucky to be here at all. On the other hand, the filter might be ahead of us, waiting in our future. Some catastrophe or limit that almost every civilization eventually crashes into before they can travel the stars. Nuclear war, climate collapse, uncontrolled technology, something universal and destructive that prevents intelligence from spreading across the galaxy. And that's where the unease creeps in. Because if the filter is in our past, we might be safe. But if it's in our future, then we may not have much time left. The silence of the universe becomes less of a mystery and more of a warning. If you step outside on a clear night and look up, the sheer number of stars can feel overwhelming. Our galaxy alone, the Milky Way, is home to somewhere around 200 to 400 billion stars. Many of those stars are older than the Sun. Many of them have planets orbiting around them. And with modern telescopes, we've learned that planets are not rare at all. In fact, most stars seem to host them. There are worlds bigger than Jupiter, worlds smaller than Earth, rocky planets that might have oceans, icy moons with hidden seas. the universe is full of real estate. By all accounts, the galaxy should be alive with possibility. Yet, when we tune our instruments to listen for signs of intelligent life, the static goes on and on. That's the puzzle. The silence isn't what we expect. It's almost as if you walked into a giant stadium, saw every seat filled, and then realized that not a single person was making a sound. Not even a cough, a cheer, or the rustle of movement. Just the hum of the lights above and the echo of your own breath. It doesn't fit with the numbers. It doesn't fit with the odds. Because even if intelligent life is rare, the galaxy has had billions of years to let it bloom, flourish, and spread. We humans have only been broadcasting radio waves for about a century. That's a blink of an eye compared to the age of the universe. If other civilizations got even a small head start, they should be way ahead of us by now. This question is sometimes called the Fermi paradox, after Enrico Fermi, who voiced it. So plainly, where is everybody? You'd expect the cosmos to be noisy, busy, humming with signals from advanced societies. And yet all we hear is silence. No obvious alien radio broadcasts. No giant space structures blocking starlight. No clear evidence that anyone has ever passed this way. Just us on our small pale planet trying to convince ourselves that maybe one day we LL here ILO. Some people might shrug and say, well, maybe we just haven't looked hard enough. And it's true. We've only scanned a tiny fraction of the stars out there. Our technology is still young. For all we know, the signals are there, but faint, like whispers across a canyon that we haven't pointed our microphones toward yet. Or maybe the signals come in bursts once every 1,000 years, and we just happen to miss them. The search for extraterrestrial intelligence, often called SETI, is ongoing. But it's a little like standing on the shore of the ocean, with a cup scooping out water and saying confidently, I don't see any whales in here. We've only sampled a sip of the ocean, compared to what's out there. But even with those limits, the silence still feels strange. You'd think that if advanced civilizations were common, some of them would have built things we could see even from far away. Imagine a species far older and more advanced than us building vast energy collectors around their star, sometimes called Dyson spheres. These megastructures would give off telltale signs of waste heat, and telescopes should be able to notice something unusual. But surveys of thousands of stars have turned up nothing definitive. There are a few odd cases, like a star called Tabby's star, that dimmed in strange ways, sparking speculation. But natural explanations, dust, comets, or just the quirks of stellar physics remain more likely. So, the puzzle deepens. If intelligent life is supposed to be probable, why does the universe look so empty? Scientists have offered many answers, and some are almost comforting. Perhaps alien civilizations are out there, but they're too far away for us to detect. Or maybe they communicate in ways we haven't thought to look for. Instead of radio, maybe they use neutrinos, or quantum entanglement, or something beyond our current imagination. In that case, the silence is simply a mismatch of technology, not a true absence. Other explanations are more sobering. Maybe civilizations self-destruct before they can spread far enough to be noticed. Maybe they run into the same problems we fear for ourselves. Wars, resource collapse, climate disasters, runaway artificial intelligence. If so, then the silence of the universe might be less about distance and more about destiny, a pattern that repeats over and over. Civilizations rise, shine for a brief cosmic moment, and then fade. The silence can feel eerie in another way, too. It's not just about whether we hear signals or not. It's about the fact that the universe itself has been around long enough for someone somewhere to have made themselves visible. The galaxy is about 13 billion years old. Our solar system is only about 4.5 billion. That means there were billions of years before Earth even formed, when other civilizations could have gotten started. Imagine a civilization with a billion-year head start. A billion years is enough time to do almost anything. colonize the galaxy, build unimaginable technology, create networks of stars linked together. If even one of those civilizations had survived and spread, we would see traces everywhere. And yet, we don't. This contradiction has made people wonder if there's some universal barrier in place, some reason why life either doesn't start often or doesn't make it very far when it does. And that's where the idea of the great filter comes in. But before we get ahead of ourselves, it's worth appreciating how strange the silence really is. Because silence in this context isn't neutral. It's information. Every time our telescopes scan the sky and find nothing unusual, that's another clue. It's a quiet clue, but it suggests something about the nature of the universe, and maybe even about our own fate. Still, humans are storytellers, and when we face silence, we can't help but fill it with our own ideas. Some imagine the universe is teeming with life, but everyone is deliberately quiet, like neighbors pulling their blinds down when someone walks by. This is sometimes called the zoo hypothesis, the idea that Earth is being watched, but no one is allowed to interfere. Others suggest civilizations reach a point where they retreat inward, building virtual worlds so perfect that they no longer care about outer space. In that case, the silence comes not from destruction, but from indifference. The universe might be full of life, but everyone is too busy with their own digital utopias to send a postcard. And then, of course, there's the possibility that we really are the first, that we're early, that intelligence is just beginning to emerge in the galaxy, and for some reason, Earth got a head start. In that case, the silence isn't ominous. It's simply the sound of a play that hasn't yet begun. We might be sitting in the theater before the curtain has gone up. If that's true, then the future could still be loud, vibrant, full of voices yet to come. But we can't shake the unease because the silence can't easily be explained away. Every answer opens new questions. If aliens are quiet by choice, why all of them? If they're destroyed, why every civilization? If we're the first, why us? When so many stars and planets had a head start. The quiet feels heavier than simple emptiness. It feels like something is missing that should be there. Like hearing a symphony orchestra tune up and then realizing the conductor never walked onto the stage. The puzzle of silence is not just an astrophysical riddle, it's also a mirror. It reflects our own hopes, fears, and uncertainties about what's ahead. When we look out and hear nothing, part of us wonders if the same fate awaits us. That maybe we are destined to vanish into the same quiet that seems to blanket the galaxy. And yet, another part of us dares to hope that silence is simply a pause waiting for us to add our voice. If you've ever had a question pop into your head at the wrong time, then you'll understand how this whole mystery began. It was the summer of 1950 in Los Alamos, New Mexico. A group of physicists were out for lunch talking about everything from nuclear research to comic strips when Enrico Fermi suddenly asked a question so blunt and so obvious that it cut through the chatter like a glass falling off the table. He simply asked, "Where is everybody?" Everybody in this case didn't mean colleagues who were late to lunch. Fermi was talking about aliens. Intelligent life beyond Earth. The kind of life that, statistically speaking, should have appeared long before us. The galaxy is unimaginably old, billions of years older than our own planet. With so many stars, so many planets, and so much time, you'd expect civilizations to be everywhere. They should have risen, spread, and left traces of themselves all across the galaxy. But when we look out, we don't see them. We don't hear them. Nothing. The people at that lunch laughed, of course. They made jokes about flying saucers and newspaper headlines. But the question stuck, and over time, it became known as the Fermi paradox. A paradox because the numbers suggest one thing: life everywhere, while the evidence shows the opposite: life nowhere. At least none that we can detect. It's a paradox that lives in the tension between probability and reality. Think of it this way. If you walk into a forest with thousands of trees, you'd expect to hear birds. If you spend hours in that forest and hear nothing at all, no wings, no chirps, not even the rustle of feathers, you might start to wonder if something strange has happened. Maybe the birds are hiding. Maybe they're using a frequency you can't hear. Or maybe, for some reason, this vast forest is simply empty. That uneasy quiet is exactly what Fry was pointing at. To understand why his question carries so much weight, you need to look at the math behind it. The galaxy contains hundreds of billions of stars. Current estimates suggest that at least half of those stars host planets, and many of those planets sit in the so-called habitable zone, where liquid water could exist. Even if life starts on just a small fraction of those worlds, you'd still end up with millions of possible planets where biology could take hold. And if evolution works anywhere remotely like it did here, some of those life forms should eventually become intelligent. They should invent tools, build cities, and start wondering about the stars just like we do. Now, imagine one of those civilizations had a head start of just a few million years. That's a tiny sliver of time compared to the age of the galaxy. In that head start, they could have developed technologies far beyond our own. They could have spread across their star system, sent probes to neighboring stars, maybe even colonized half the galaxy. 1,000,000 years is an eternity in technological terms. We went from horse-drawn carts to rockets in a few centuries. What could someone do with 10,000 centuries? The possibilities are staggering, which makes the silence all the more puzzling. Because if even one civilization had expanded, their presence should be obvious. They wouldn't need to cover the galaxy with cities or starships. Just by building massive structures or sending signals, they'd leave fingerprints. And yet, when astronomers scan the sky, what they find is nothing unusual. Just stars, gas, dust, and the occasional oddity that usually turns out to be natural after closer inspection. So, where is everybody? Some suggest that the question might not even make sense the way we're asking it. We assume that intelligent life would expand outward, make noise, and leave traces. But what if alien civilizations behave differently? Maybe they're cautious. Maybe they hide on purpose. Maybe they reach a certain level of technology and then turn inward, creating digital worlds so absorbing that outer space becomes irrelevant. If that's the case, they'd be invisible to us, not because they're absent, but because they're uninterested. Others argue that the evidence might still be there, but we don't yet have the tools to recognize it. We listen for radio waves, but what if advanced civilizations communicate in ways we can't even imagine? Instead of radio, maybe they use neutrinos, gravitational waves, or some method so advanced it would look like background noise to us. It would be like a fish trying to detect Wi-Fi. It wouldn't even know what to look for. But there's a darker interpretation of FN's question, one that leads directly into the great filter. Maybe civilizations do appear, but something almost always stops them before they can spread. They rise, they thrive for a while, and then they collapse. War, environmental destruction, runaway technologies, whatever the reason, they don't make it far. And that's why the galaxy is silent. Not because no one ever tried, but because no one ever survived long enough to leave a mark. It's worth pausing to notice how human this question feels. On the surface, it's about astronomy and math, but underneath, it's about us. When we ask where everybody is, what we're really asking is what does their absence say about our own future? If the galaxy is empty, does that mean life is incredibly rare, and we are a lucky exception? Or does it mean that life is common, but survival is not, and we are just waiting for the same fate? The Fermi paradox doesn't give answers. It simply sharpens the problem. It tells us that something is off, that the numbers don't add up. It leaves us with a silence that could mean almost anything. A silence that might be a comfort, a warning, or both. And yet, humans are not good at leaving questions alone. We build frameworks to try to explain them. Equations, theories, hypotheses. The most famous of these frameworks is the Drake equation, which tries to break down the odds of civilizations existing into smaller, measurable steps. It doesn't solve the paradox, but it gives us a way to talk about it, a way to structure our uncertainty. When you think about it, Firm's simple lunchtime question might be one of the most profound ever asked. In 4 words, where is everybody? He forced us to confront both the immensity of the universe and the fragility of our place within it. It's the kind of question that lingers even when you're not looking at the stars. It pops up while you're waiting for the kettle to boil, or scrolling through news headlines or drifting off to sleep. Because once you hear it, you can't unhear it. The silence feels louder. The absence feels heavier. When you look up at the night sky, it can feel like there are more stars than you could ever hope to count. The truth is, even if you spent your entire life trying, you'd only scratch the surface. Our own galaxy, the Milky Way, is estimated to hold somewhere between 200 and 400 billion stars. That's such a large number, it almost slips past comprehension. If you tried to count 1 star per second, you'd still be at it for thousands of years without even finishing our corner of the cosmos. And remember, that's just one galaxy. Beyond it lie trillions more scattered across the universe, like a vast ocean of lights, each with its own collection of planets, moons, and mysteries. Astronomers sometimes talk about the cosmic lottery. Each star is a ticket. Each planet is a ticket within a ticket. And when you add them all together, the odds of life starting somewhere else should be enormous. For most of human history, we didn't know how many planets there were. People assumed they might be rare, perhaps unique to our solar system. But in the last few decades, thanks to telescopes like Kepler and TESS, we've discovered thousands of exoplanets, planets orbiting distant stars, and the evidence points to them being everywhere. Nearly every star seems to host at least one. Some have whole families of them, orbiting in graceful arrangements like distant solar systems mirroring our own. Among these planets are worlds that sit in what astronomers call the habitable zone. That's the region around a star where it's not too hot, not too cold, but just right for liquid water to exist. Water is one of the key ingredients we associate with life. And so the habitable zone is sometimes nicknamed the Goldilocks zone. It is not a guarantee of life, but it's a promising start. And when you think about how many stars there are, and how many of them probably have planets in this comfortable region, the number of potential homes for life starts to become staggering. This is where optimism often kicks in. If the galaxy is filled with billions of potentially habitable planets, then surely, at least on some of them, life must have taken hold. And if life can arise once, why not more than once? After all, on Earth, it seemed to happen relatively quickly once the conditions were right. The earliest signs of life here date back almost 4 billion years, not long after the planet cooled enough to support oceans. That makes it tempting to think that life is not just possible, but inevitable whenever the ingredients come together. But raw numbers don't always tell the whole story. Imagine buying a lottery ticket. The odds of winning might be 1 in 100 million. If you buy a single ticket, your chances are slim. But if 100 million people all buy a ticket, somebody is almost guaranteed to win. The universe, with its vast supply of stars and planets, looks like a place where someone should have won by now. Someone should have beaten the odds and made themselves known. Yet, when we listen for signals or scan the skies, the silence continues. It's as if we're holding all these tickets, waiting for the announcement, and nothing ever comes. This tension between numbers and outcomes is part of what makes the Great Filter so unsettling. The stars suggest abundance. The planets suggest opportunity. Evolution on Earth suggests that once life gets going, it can flourish into complexity. And yet, the lack of evidence suggests that something in this chain of events must be far rarer than it appears. Either the step from chemistry to biology is much harder than we think, or the step from biology to intelligence is, or perhaps intelligence almost always stumbles before it can reach beyond its home world. The Drake equation is often brought in here, a kind of rough formula for thinking about these numbers. It was developed in the 1960s by astronomer Frank Drake as a way to organize our ignorance. The equation takes the rate of star formation, multiplies it by the fraction of stars with planets, then by the fraction of those planets that could support life, and so on until you reach the expected number of detectable civilizations in the galaxy. Each term is filled with uncertainty, but the structure of the equation helps break the problem down. It reminds us that the silence we hear isn't just about one number. It's about a chain of probabilities, each one multiplying the chances of us finding neighbors. When scientists fill in the equation with optimistic values, the result is often thousands or even millions of civilizations. When they fill it in with pessimistic guesses, the result is close to zero. The wide range itself tells you something. We don't really know which step is the hardest. Maybe life is common, but intelligence is rare. Maybe intelligence is common, but survival is rare. Maybe we're missing something altogether. Some hidden factors we haven't even considered. The thing about counting chances is that it forces you to confront just how many opportunities the universe has had to produce life. Earth is not unique in its chemistry. The elements that make up our bodies, carbon, hydrogen, oxygen, nitrogen, are among the most abundant in the cosmos. The processes that shaped our planet, gravity, plate tectonics, the chemistry of water, are not exotic either. When you tally it all up, it feels like we should not be alone. And yet, every time we look, we come back empty-handed. Some researchers frame it this way. Either we are extraordinarily rare, or we are in extraordinary danger. If life is rare, then perhaps we are alone, and our existence is the result of an almost miraculous sequence of events. If life is not rare, then the silence suggests that something else is at play, some common obstacle that stops civilizations from lasting long. The first scenario is lonely but hopeful. We are special, and we might survive. The second is crowded but grim. We're not special, and the filter is waiting for us. It's hard to know which scenario is true, and the uncertainty can weigh on you when you start to think about it deeply. But at the same time, there's something strangely grounding about it. Because no matter how many stars are out there, no matter how many chances the universe has had, all we can be certain of is this one world, this one civilization right here and now. When you zoom out far enough, the statistics become dizzying. But when you zoom back in, what matters most is how we treat our own fragile chance at survival. If you've ever flipped a coin and seen it land on the same side several times in a row, you know the peculiar way probability can feel. It's supposed to be even fair, predictable over the long run. And yet, at the moment, it can deliver streaks that don't make sense. The universe is like that, too. The odds suggest that intelligent life should be out there, scattered across the stars in abundance. But the reality is a stubborn quiet. The numbers say one thing, the evidence says another, and we are left wondering whether we've misunderstood the game altogether. The strange part isn't just that life seems missing, but that the scales are so tilted. Think about the ingredients. The cosmos is built from hydrogen, helium, and a dusting of heavier elements forged in stars. Carbon, oxygen, nitrogen, iron. These are the bricks of biology, and they're everywhere. When a star explodes, it scatters these elements across space, seeding clouds that collapse into new solar systems. Planets form with these same ingredients baked in. Earth is not unique in having carbon, water, or sunlight. These are standard features of the universe. So, if the building blocks are common, why does it feel like we're the only house in the neighborhood with the lights on? One answer people often lean on is time. Maybe we're early. Maybe intelligent civilizations are still in their infancy, and we just happen to arrive before the party starts. If that's the case, then the odds will balance out in the future. Given enough time, the silence will eventually give way to a chorus of voices. It's a comforting thought, but it is also a gamble, because it assumes we'll still be around to hear them when they finally start speaking. Another answer flips the perspective. Perhaps civilizations do arise, but they don't last long. The odds of starting the fire of intelligence might be decent, but the odds of keeping it burning could be terrible. Maybe every civilization eventually makes a mistake it can't recover from. They reach for technology that outpaces their wisdom. They exhaust their resources, or they trigger disasters they cannot control. In that view, the silence is not a sign of emptiness, but of fragility. Everyone gets their brief chance at cosmic company, but the odds of surviving long enough to meet each other are slim. Then there's the possibility that life itself, even at the microbial level, is far rarer than we think. We know it happened here, but we don't yet know if it's ever happened anywhere else. People sometimes point out that we have only one data point, Earth, and one data point cannot establish probability. Maybe life's origin is an almost impossible event, a freak accident in chemistry that required such precise conditions it might never happen again. If that's true, then we may be profoundly alone. The odds of company might be close to zero, and the silence isn't strange at all. It's exactly what you'd expect in a universe where we are the only ones. Still, it's difficult to reconcile that idea with just how quickly life seems to have appeared on Earth. Geological evidence suggests that life began not long after the planet cooled enough for oceans to form. Within a few 100 million years, the first microorganisms were already thriving. If life were impossibly hard to spark, why did it happen so fast here? That speed hints that the odds might actually favor life, at least in simple forms. Which brings us back to the strange mismatch between expectation and observation. Suppose for a moment that life is common. Microbes bloom across countless planets, filling oceans, soils, and atmospheres. Even if most of those ecosystems remain microbial, surely some should make the leap to complexity. Evolution, given enough time, tends to explore possibilities. On Earth, it led to multicellular creatures, to nervous systems, to intelligence. If that process isn't unique to us, then there should be other worlds with minds looking outward. And yet, when we listen, the only voice we hear is our own. This is why people sometimes describe the paradox as eerie, even unsettling. It's not just that we don't see aliens. It's that the numbers practically demand them, and their absence feels like the punchline to a cosmic joke. Imagine going to a concert in a stadium that seats 100,000 people. The tickets are sold out, the lights are on, the stage is set, and then the band never shows. The odds said you are about to experience music, but all you get is silence and the buzz of the lights overhead. That gap between expectation and reality is where the unease creeps in. There are, of course, more imaginative answers. Some suggest that intelligent life exists, but it's so different from us that we wouldn't recognize it even if we saw it. Maybe it doesn't use technology the way we do. Maybe it communicates in ways that don't leave obvious traces. Maybe it lives in forms and scales we can't yet imagine. Creatures spread across gas clouds or consciousness embedded in magnetic fields. If that's the case, then the odds of company aren't low at all. We're just failing to notice the neighbors because we're expecting them to look and act like us. Others propose the idea that civilizations eventually go quiet on purpose. Once they realize the universe is dangerous, filled with unknowns, they stop broadcasting. They pull the blinds, dim the lights, and hope no one notices them. This is sometimes called the dark forest idea. The universe is a dark forest where every civilization is a hunter, and making noise is a way of inviting disaster. In that world, the odds of company are high, but the odds of hearing from them are practically zero. Everyone is there, but everyone is hiding. Each of these explanations reshapes how we interpret the silence, but none of them fully resolve the paradox. The odds still feel strange, tilted, lopsided. We should not be alone, and yet we might be. We should hear voices, and yet we don't. Every time a new telescope launches, hope rises that maybe this time we'll catch a signal or glimpse a structure that breaks the pattern. But so far, the pattern holds. Stars, planets, silence. And so we are left with two possibilities, both of which are humbling. Either the odds are wrong, and we have overestimated how likely a company really is, or the odds are right, and the silence means something has been happening to civilizations that reach a certain point. In either case, the implications for us are profound. Because whether the universe is empty by nature or emptied by fate, the silence forces us to confront our own fragility, our own future, and the slim odds that we too might survive long enough to change the story. When people hear the phrase "the great filter," the first reaction is usually confusion. It doesn't sound like something from astrophysics. It sounds more like something you de-screw onto your kitchen tap or a part of a coffee machine. But in the world of cosmic puzzles, the great filter is one of the most unsettling ideas we've come up with. And understanding it begins with asking a very simple question. Out of all the steps it takes to go from a lifeless rock to a spacefaring civilization, which ones are easy and which ones are hard? The idea is that somewhere along the chain of development, there are barriers so tough, so unlikely, that almost nobody gets past them. These barriers are the filters. And if we accept that the galaxy should be alive with civilizations, but appear empty, then the conclusion is that most civilizations fail at one of those barriers. They hit the filter and stop. That's why we don't see them. That's why the stars are quiet. So what are these steps? Imagine the journey laid out as a ladder. At the bottom, you start with a planet that has the right conditions, stable temperatures, the right chemistry, maybe some liquid water. From there, life has to get started at all. That first step from chemistry to biology might be one of the hardest. We don't actually know how it happened on Earth. We have hypotheses, experiments that show how building blocks like amino acids can form. But we still don't know the exact path from lifeless molecules to living cells. If that step is incredibly unlikely, then life itself might be rare. Maybe we already passed the great filter, and we're the lucky exception. But let's assume life is not impossible. On Earth, once it got going, it seemed to adapt and thrive in all sorts of environments. Microbes lived in oceans, deep underground, near volcanic vents, even inside rocks. If life is that adaptable, then maybe it's common across the galaxy. In that case, the filter might be higher up the ladder. The next steps involve life becoming complex. For billions of years on Earth, life stayed microscopic. Simple cells ruled the world for an almost unimaginable length of time. Then eventually, multicellular life appeared, and things took off. Creatures with organs, nervous systems, and the capacity to move and sense the world around them evolved. If that leap is rare, maybe most planets stay microbial forever. Whole oceans of bacteria and algae, never inventing cities or telescopes. If that's the case, we pass the filter when life becomes complex here. And then there's intelligence, not just tool use. Plenty of animals on Earth use tools, but the kind of intelligence that builds cumulative culture, language, technology, and eventually rocket ships. That might be another filter. Dinosaurs ruled the Earth for 150 million years without ever building a radio. It took a very particular evolutionary path with all sorts of accidents and extinctions to end up with us. Maybe intelligence is an anomaly, and most worlds never stumble across it. But suppose they do. Suppose intelligence isn't the hardest step. There's still the matter of survival, because once you reach a certain level of power, you also reach a certain level of risk. You invent nuclear weapons. You change your planet's climate. You create technologies you don't fully understand. Every step forward is also a step closer to stumbling. The great filter in this view isn't in the past, it's in the future. Civilizations almost always destroy themselves before they can expand beyond their planet. They crash into their own power and collapse. That would explain the silence. Everyone who reaches our stage of development has a short shelf life. And of course, there's the possibility that the filter isn't just one barrier, but several. A whole series of difficult steps, each narrowing the field until only a few or perhaps just one makes it all the way through. That would mean our existence is already remarkable. But it also means our survival is far from guaranteed. The unsettling part is that we don't know where the filter lies. If it's behind us, then the galaxy might be filled with planets rich in simple life, but almost none of them ever climbed as far as we did. In that case, our existence is extraordinarily rare and precious. If it's ahead of us, then our odds of survival are grim. The silence would be a warning that most civilizations at our stage don't last long. If it's a mix of both, then we may have passed some filters already, but still face more in the future. It's worth pointing out that this idea isn't just speculation for its own sake. It comes from trying to reconcile the numbers. We know the universe is vast. We know planets are common. We know the building blocks of life are abundant. And yet, we see nothing. The great filter is one way of making sense of that contradiction. It's not that the odds are broken. It's that something in the chain is far rarer or more dangerous than it looks. Think of it like walking through a forest after a storm. You see fallen trees everywhere, trunks splintered, branches broken. You know, the storm was the filter. Most trees couldn't withstand it. A few survived, but most didn't. The great filter is the cosmic equivalent of that storm, except instead of trees, it's civilizations. And instead of wind, it's some barrier we don't fully understand. Some people find this idea terrifying. If the filter is ahead, then our future may be bleak. If it's behind, then we might be alone in the galaxy forever, which is lonely in its own way. But others find it strangely motivating. If we know the odds are stacked against survival, then maybe that knowledge can push us to be cautious, to value what we have, to avoid the mistakes that might doom us. The great filter in that sense isn't just a hypothesis. It's a mirror we hold up to ourselves. And maybe that's the most important part, because whether the filter is real or not, thinking about it forces us to confront questions we often prefer to ignore. How resilient is our civilization really? How well are we managing the risks that come with our own technology? How fragile is our place in the grand timeline of the universe? These aren't abstract questions. They about us here and now, living on a small planet under a silent sky, wondering if we'll be the exception or just another example of the rule. When we talk about the great filter, one of the big questions is whether it lies in our past. If it does, then the silence of the galaxy isn't a warning about what's coming, but a reflection of just how improbable it was that we ever made it this far. To understand that possibility, you have to trace the story of life on Earth from its very beginning, and notice just how many unlikely steps had to line up in our favor. The path from molecules to minds looks obvious in hindsight, but each rung of the ladder could have been a dead end. Start at the very bottom with a lifeless planet orbiting a young star. The early Earth was a chaotic place, a world of volcanic eruptions, asteroid impacts, and a surface that was only just settling into stability. Somewhere in that turmoil, chemistry began doing something unusual. Simple molecules like methane, ammonia, and water collided, broke apart, and recombined. Lightning, ultraviolet light, and geothermal heat all provided energy to drive reactions. Out of that chemical soup came more complex molecules, amino acids, lipids, nucleotides, the building blocks of proteins, membranes, and genetic material. The leap from chemistry to biology is still one of the greatest mysteries in science. We don't know exactly how it happened or how likely it was. Some experiments show that basic building blocks can form easily under the right conditions. But going from building blocks to a self-replicating system is a whole other challenge. Life needs a way to copy itself, a way to store information, and a way to create order out of chaos. On Earth, molecules like RNA and DNA eventually filled that role. But whether that was inevitable or a 1 in a trillion accident is unclear. If this first step is nearly impossible, then perhaps that's the great filter. Life itself may be the barrier. Maybe Earth is the exception, a lucky roll of the cosmic dice that produced something vanishingly rare. If that's true, then the silence of the stars isn't a mystery at all. It's exactly what we'd expect in a universe where life almost never begins. In that case, the filter is already behind us. And though it means we might be alone, it also means our future isn't necessarily doomed. But suppose life isn't impossibly rare. Suppose that once conditions are right, it sparks fairly often. Even then, the story doesn't get simple. For billions of years after it began, life on Earth was incredibly basic. Microbes dominated. They lived in oceans, clung to rocks, thrived in mud, and shaped the planet's atmosphere. For 2 billion years, Earth was a microbial world, and nothing more complex ever seemed to appear. That long plateau suggests another possible filter. The step from single-celled life to multicellular organisms may be incredibly difficult. Multicellularity requires cooperation. It means cells giving up some independence to work as part of a larger whole. It requires communication, specialization, and trust that individual cells will benefit from supporting the group rather than just competing. On Earth, it took billions of years before that step finally happened. And even then, it seems to have been rare. Only a handful of lineages made the leap. Plants, fungi, animals, and almost everything else stayed single-celled. If this step is unlikely, then most planets with life might still look like Earth did 3 billion years ago. Rich with microbes, but without forests, fish, or birds. Even once multicellularity appeared, intelligence wasn't guaranteed. Earth's history is filled with countless species that lived and thrived without ever inventing technology. Trilobites, ammonites, dinosaurs, entire kingdoms rose and fell without building a single tool more complicated than a claw or a shell. Intelligence in the sense of abstract reasoning, communication, and long-term planning seems to have been a rare evolutionary strategy. It worked for us, but it wasn't the only path to survival, and it certainly wasn't the most common. Consider the dinosaurs. For 150 million years, they dominated the Earth. They adapted to every climate, filled every niche, and grew to astonishing sizes. Yet, in all that time, none of them developed language or culture in the way we understand it. None of them built a fire or carved a wheel. If intelligence were inevitable, you might expect them to have gotten there long before mammals appeared. The fact that they didn't suggest that even with multicellularity, even with brains, the leap to a species like ours is anything but guaranteed. So maybe that's where the filter lies. Maybe microbial life is common. Maybe multicellularity even happens now and then. But intelligence, true technological intelligence, is so rare that it's almost unique. In that case, the galaxy could be full of life, but almost none of it is capable of building radios or telescopes. The silence again makes sense. We're not hearing anyone because there is nobody out there who has the tools to speak across the stars. And then is the matter of timing. Our own evolutionary story hinged on a series of accidents. About 66 million years ago, an asteroid struck Earth and wiped out the dinosaurs. That disaster cleared ecological space for mammals to thrive, eventually giving rise to primates and eventually to us. Without the asteroid, maybe intelligence never would have appeared here at all. Maybe Earth would still be ruled by reptilian giants. If intelligence depends on that kind of random catastrophe, then the odds shrink even further. The galaxy might be filled with planets where life thrived for billions of years, but never rolled the dice in quite the same way. From there, you can trace the chain forward. Humans evolved, learned to use tools, developed language, and built societies. Each step added another layer of complexity. Agriculture allowed populations to grow. Writing allowed knowledge to be preserved. Science allowed us to understand the world in ways no species before us ever had. But none of that was inevitable. Each step required specific conditions, cultural shifts, and lucky breaks. If any of them had gone differently, our story might have ended long before we invented rockets and satellites. Looking back at this path, it's easy to see why the idea of past filters is so compelling. There are so many points where life could have stalled or collapsed or never appeared in the first place. The fact that we're here at all might mean we've already cleared the hardest hurdles. The silence of the universe could simply mean that almost nobody else ever did. If that's true, then the implications are profound. It would mean we're rare, perhaps even unique. It would mean the universe isn't empty because civilizations destroy themselves, but because they never get started in the first place. It would mean the great filter is behind us. And our task now is simply to avoid self-sabotage and make use of the incredible luck that got us here. Of course, the trouble is, we don't know. We can't replay the tape of Earth's history to see how often life starts, how often multicellularity appears, and how often intelligence evolves. We only know the path that led to us. And it might be typical, or it might be 1 in a billion. Until we find life elsewhere, or even microbial, the question remains open. Every discovery of an exoplanet, every probe sent to Mars or Europa or Enceladus is part of the search for another data point. If we ever find life beyond Earth, even simple bacteria, it would suggest that life itself is not the hardest filter. That would shift the focus to the higher steps, complexity, intelligence, survival, and change how we interpret the silence of the stars. Until then, we're left with uncertainty. And maybe that's fitting, because the story from molecules to minds is not just a scientific puzzle. It's also a reminder of how precarious our own existence is. The fact that you re-hear listening is the result of an unbroken chain of unlikely events stretching back billions of years. Every ancestor who survived long enough to pass on their genes. Every accident that tilted the odds in our favor. Every quirk of chemistry and geology that made Earth what it is. All of it had to happen just so. If even one link in that chain had broken, we wouldn't be here to wonder about filters at all. And that perspective, while unsettling, can also be grounding. Because whether or not we've passed the great filter already, what's certain is that we carry the weight of that improbability. We are for now the only known minds in the cosmos capable of asking these questions. That makes our survival not just a scientific curiosity, but a responsibility. The silence of the stars could mean we're alone. If so, then protecting and sustaining this fragile civilization is not just important for us. It might be important for the universe itself. When people first hear about the great filter, they often hope it's behind us. It's a comforting thought. Maybe life itself is so hard to spark that we've already cleared the hardest step. Maybe intelligence is so rare that we're the only ones who manage it. In that case, the silence of the universe would mean we re-special, and our future might stretch ahead without invisible barriers waiting to cut us down. But the darker possibility is that the great filter isn't in the past at all. It's still ahead of us, lying in wait, and we haven't yet reached the roadblocks that destroy most civilizations. That's the unsettling interpretation, the one that turns the silence of the stars from mystery into warning. Think about what happens when a species gains power. At first, power means fire, tools, farming. It means being able to shape the environment just enough to survive. But power compounds, it grows. In just a few thousand years, humans went from stone blades to nuclear warheads, from clay tablets to supercomputers, from watching the sky with naked eyes to sending probes beyond the solar system. That acceleration is breathtaking, but it's also dangerous because the more power a civilization has, the more ways it gains to accidentally or intentionally destroy itself. One obvious candidate for a future filter is nuclear war. Since the mid-20th century, humanity has lived under the shadow of weapons powerful enough to wipe out not just armies, but entire cities, countries, even civilization itself. The Cold War brought the world to the edge more than once. And while the risk has changed shape since then, the weapons are still here. They sit in silos, submarines, and bunkers, waiting for human error, miscalculation, or madness. A full-scale nuclear exchange wouldn't just kill millions immediately. It would throw dust and soot into the atmosphere, blocking sunlight, collapsing agriculture, and plunging the world into what scientists call nuclear winter. Civilizations like ours are fragile, and a disaster of that scale could knock us back centuries or end us outright. But nuclear war is just one possibility. Another filter could be ecological collapse. We already know that our planet has limits. We depend on stable climate systems, clean water, fertile soil, and functioning ecosystems. Push those systems too hard, and they break. Climate change is the most obvious example. A slow-moving crisis that could make large regions uninhabitable, disrupt food supplies, and create widespread conflict. But there are other risks too. Mass extinctions that unravel ecosystems, pollution that poisons oceans and air, resource exhaustion that leaves us fighting over what remains. If civilizations everywhere exploit their planets the way we have, maybe most of them eventually tip their worlds into collapse before they ever leave home. Then there's technology itself. Every powerful invention carries not only benefits, but risks. Artificial intelligence is one example. A system that can learn, adapt, and act on its own could transform civilization. But if it escapes our control, it could also end it. Biotechnology is another. The ability to edit genes or create new organisms could cure diseases, but it could also release plagues more devastating than anything nature ever made. Nanotechnology, if it becomes advanced enough, could be used to build wonders or to unleash what theorists call gray goo, self-replicating machines that consume everything in their path. Each of these ideas sounds like science fiction, but so did nuclear bombs a century ago. The point isn't that any one of them is inevitable. The point is that as power increases, so do the chances of catastrophic misuse. Sometimes the filter might not even be deliberate. It could be an accident. Imagine a civilization that develops a new technology without fully understanding it. They flip the switch, and instead of prosperity, they trigger collapse. Maybe it's an energy source that destabilizes their planet's climate. Maybe it's an experiment that spirals out of control. History is filled with examples of humans underestimating the consequences of their actions. Multiply that by technologies capable of planetary scale impact, and you have a recipe for self-destruction. Another possibility is stagnation. Not dramatic collapse, but slow failure. A civilization might rise to great heights, but then lose the ability or the will to keep advancing. Maybe they exhaust their resources before reaching the stars. Maybe political systems fracture and progress stalls. Maybe they turn inward, building virtual worlds so absorbing that exploring the galaxy no longer matters. In that case, civilizations don't vanish suddenly. They simply fade, trapped in their home worlds, never making it far enough for others to notice. The galaxy stays silent, not because everyone was destroyed, but because nobody ever left. The Great Filter might also involve cosmic events outside a civilization's control. Planets can be struck by asteroids, as Earth was 66 million years ago. Stars can unleash bursts of radiation powerful enough to sterilize nearby worlds. Galaxies can produce supernova and gamma-ray bursts that sweep across space like invisible sides. On cosmic timescales, these disasters are not rare. If civilizations don't spread beyond their home planets quickly enough, they might be wiped out by forces far larger than themselves. Put all of this together, and you start to see the picture. The future is filled with roads that may not be survivable. Nuclear war, environmental collapse, uncontrolled technology, cosmic accidents. Any one of them could explain the silence we see. Perhaps most civilizations eventually stumble into one or more of these traps, and very few, if any, make it through. If that's true, then the great filter lies ahead of us, and the odds of surviving it are slim. This possibility is hard to face, because it means the silence of the universe is unreassuring at all. It's not the quiet of a galaxy where we've already beaten the odds. It's the quiet of a graveyard, where civilizations like ours burn brightly for a time, and then vanish before anyone else can hear them. We may be looking out at the future of countless others and seeing only their absence. But it's worth noting that knowing about these risks doesn't have to lead only to despair. If the great filter is ahead, then the fact that we're thinking about it now might give us an advantage. Awareness is a kind of defense. We can choose caution. We can design safeguards. We can try to avoid the mistakes that might have doomed others. Maybe that's the real test of intelligence. Not just the ability to build powerful tools, but the wisdom to survive them. Even so, the question lingers. How many ways are there to fail? And how many ways are there to succeed? Is survival the rare exception? Or is it something that civilizations can learn if they're careful enough? The great filter in the end isn't just a theory about others. It's a challenge set before us. We don't know if we'll pass it, but the silence of the stars suggests that not many do. When people think about the great filter, their minds often jump to two extremes. Either it's behind us, and we're one of the rare lucky few who made it through, or it's still ahead, waiting to stop us in our tracks. But there's another possibility that doesn't get as much attention. Maybe the universe is quiet because we're early, not doomed, not unique, just early. The cosmic stage is set, but the actors haven't shown up yet. And here we are sitting in the empty seats, wondering why the theater is so quiet. At first, this idea might sound unlikely. After all, the universe is more than 13 billion years old, and our solar system has only been around for about 4 billion. Stars and planets were forming billions of years before Earth even existed. If civilizations could arise, why didn't they start long ago? Shouldn't we be seeing the results of billion-year head starts? Galaxies spanning empires, signals crisscrossing space, structures larger than worlds. The silence seems to argue against the idea that we're just waiting for the party to start. But timing in the universe is complicated. For one thing, the early universe wasn't exactly friendly to life. In its first few billion years, stars were forming rapidly, but many of them were massive, unstable, and short-lived. They burned hot, exploded as supernova, and filled space with radiation. Heavy elements like carbon, oxygen, and iron, the ones we rely on for planets, for chemistry, for life itself, had to be forged inside those stars and scattered into space by their deaths. In other words, the first generations of stars may not have had the ingredients for life at all. It took time for the universe to enrich itself, recycling star after star before planets like Earth could exist. If that's true, then maybe life couldn't have started much earlier than it did here. Maybe 4 or 5 billion years ago really was the first window of opportunity for biology. If so, then the fact that we're here now isn't strange. It's just that this is when the conditions finally lined up. In that case, the silence isn't ominous. It's just the quiet of an empty room before everyone arrives. Another angle is the pace of evolution itself. Even once a planet forms, even once life begins, it can take billions of years for intelligence to appear. On Earth, simple life showed up quickly, but complex multicellular organisms didn't appear until about 600 million years ago. Intelligence capable of technology. That's only been around for a few hundred years, a blink compared to the planet's age. If that's typical, then even on planets where life exists, intelligent life might still be in its microbial or early animal stages. The universe might be full of oceans and forests teeming with creatures, but very few of them have gotten around to building radios yet. There's also the possibility that civilizations take time to spread. Even if intelligence appears, expanding across the stars isn't easy. The distances are enormous. The resources required are staggering, and the risks are high. Maybe there are civilizations out there, but they're still local, still learning, still working up the courage and capacity to reach beyond their own systems. From our perspective, that looks like silence. From theirs, it just looks like the beginning. Thinking of ourselves as early comes with its own mix of comfort and responsibility. On the one hand, it removes some of the dread. If the great filter is mostly behind us, or if it doesn't exist in the way we imagine, then maybe the universe really will fill with civilizations in time. The silence doesn't mean danger. It just means patience. We happen to show up near the start, and we re-listening before most others are ready to talk. On the other hand, being early could mean we have a special role. If intelligent life is only just beginning to appear, then how we behave might set the tone for what comes next. Our survival, our choices, our ability to expand could shape not just our own future, but the future of every civilization that follows. It's a strange thought, isn't it? That in a universe 13 billion years old, we could still be early. But history on Earth offers reminders that timing matters. Dinosaurs ruled for millions of years before mammals rose. Civilizations rose and fell before the modern world emerged. Being early or late often depends on perspective. If intelligence is only now starting to appear in the cosmos, then from our viewpoint, it feels like we're alone. From the universe's viewpoint, the story may have just begun. Still, the idea isn't free of unease. Because if we are early, then why us? Out of all the planets, all the stars, all the billions of chances, why did Earth get the first ticket? It's possible that randomness is enough of an answer. Somebody had to be first. But it's also possible that being early is itself a kind of filter. Maybe there are conditions in the universe that favor civilization starting at this particular time, and we just happen to be one of them. That would mean the silence isn't temporary. It's structurally baked into the way the cosmos unfolds. One of the most famous thoughts along these lines is something called the late filter hypothesis. It suggests that maybe life and intelligence can only appear once the universe has matured past a certain point. The earliest stars didn't have the right elements. The earliest galaxies were too chaotic. Radiation levels were too high. It might simply take billions of years for conditions to calm enough, stabilize enough for fragile systems like ours to survive. In that view, we're not early at all. We're right on time. The universe has finally cooled, quieted, and enriched itself enough for civilizations to appear. And we're just one of the first waves. More will come. Whether that's comforting or not depends on how you look at it. If others will eventually appear, then we're not alone. Not really. We're just pioneers. But pioneers face risks. Being first means there's no one to follow, no map to copy, no warning signs from others who've gone before. It also means the mistakes we make could echo louder, shaping the path for whoever comes next. When you think of it that way, the middle possibility isn't just an explanation for the silence. It's a call to maturity. If we really are early, then the universe is watching to see what we do with that head start. Do we survive long enough to become mentors for the civilizations that follow? Or do we vanish, leaving silence for them to puzzle over, just as we puzzle now? The silence of the stars always forces us to turn back on ourselves. If we are early, then our responsibility isn't just to endure, but to thrive wisely, to avoid the mistakes that might make us a cautionary tale. To remember that being first doesn't guarantee being remembered. The odds of cosmic company might eventually tip toward abundance, but only if the first voices, ours, survive long enough to welcome the next. Whenever we bring up the silence of the universe, there's always somebody who leans back and says, Maybe we're not hearing anything because the neighbors are ignoring us. And it sounds like a joke at first, but it's actually an idea that scientists and philosophers have considered seriously. It's called the zoo hypothesis. The picture it paints is exactly what the name suggests. Earth is like an enclosure in a cosmic zoo. We're inside wandering around, living our lives, and outside are more advanced civilizations watching us. They could speak to us if they wanted, but they don't because zoos are about observation, not conversation. The thought is both amusing and unsettling. On the one hand, it would explain the silence neatly. We don't hear anything because the keepers don't want us to. On the other hand, it raises a whole series of questions we might not want answered. If we are in a zoo, then who decided that? Who built it? And what rules are they following? Some versions of the idea suggest it's an ethical choice. Advanced civilizations might agree not to interfere with less advanced ones, letting them develop naturally. That way, we grow at our own pace without being overwhelmed. It's a bit like Star Trek's Prime Directive, except instead of fiction, it's a possible explanation for reality. But the zoo version can also feel darker. If we're being watched, are we being judged? Are we part of some experiment? Are we entertainment? None of these ideas are comforting. They all take the silence of the stars and twist it into something intentional. The universe isn't empty. It's ignoring us. And somehow that can feel worse than being alone. Of course, the zoo hypothesis is only one of many cosmic excuses that people have invented to explain the quiet. Another popular one is the quarantine idea. Maybe civilizations know about us, but keep their distance because we're dangerous. From their perspective, humanity looks violent, unstable, and unpredictable. If you're advanced enough to travel the stars, why risk making contact with a species that hasn't yet outgrown war, pollution, or tribal conflict? Better to let us figure things out on our own before extending a hand. Then there's the idea of deliberate silence. Civilizations might exist, but they may choose not to broadcast because broadcasting could be risky. Imagine shouting in a dark forest where you don't know what's listening. Maybe there are predators out there, more advanced civilizations that prey on weaker ones. In that scenario, staying quiet isn't rude. It's survival. Everyone hides, everyone whispers, and the result is a galaxy that feels empty, even though it's full. This is sometimes called the dark forest hypothesis. And while it comes from a work of fiction, it resonates strongly with the way some people interpret the silence. The quiet isn't absence, it's fear. There are more benign excuses too. Maybe civilizations are out there, but the timescales don't line up. Stars and planets last billions of years, but civilizations might only last thousands or even hundreds. If that's the case, then the chances of two civilizations existing at the same time and being close enough to detect each other are slim. We might have just missed the others. Their signals may have faded millions of years ago, and ours might fade long before the next one appears. In that view, the silence is simply bad timing. The universe isn't empty. It's just that no one is home right now. Another possibility is that we don't know what to look for. Our search so far has been narrow. We listen for radio waves, scan for chemical signatures, and look for giant structures. But what if advanced civilizations don't use those things? Maybe their technology looks nothing like ours. Maybe they communicate with particles we don't even know how to detect, or they live in scales and mediums we can't yet imagine. It would be like ants trying to detect Wi-Fi. The signals could be everywhere but invisible to us. If that's the case, then the silence isn't real at all. It's just ignorance. Some people take an even more radical view. Maybe we are surrounded by signs, but we can't recognize them. To a fish, a boat might just look like a strange shadow on the water. To us, an alien megastructure might just look like a peculiar star. If we don't know the signature, we might write it off as natural. Astronomers have found oddities. Stars that flicker strangely, signals that blip once and vanish. But so far, none have turned into solid evidence. Still, the possibility remains that we're seeing things without realizing what they are. The silence might be an illusion born of our own limited perspective. And then there's the possibility that civilizations do communicate, but not with newcomers. Maybe they form networks, alliances, or communities among themselves, and simply exclude species that haven't reached a certain threshold. Think of it like a galactic internet closed to outsiders until you prove you're ready. If that's the case, then Earth is still waiting for its invitation. The silence in that sense is more like a locked door. The party's happening, but we're not on the list yet. These cosmic excuses all share a theme. They give us reasons to believe that silence doesn't mean emptiness. Instead, it means something about us. We're too young, too dangerous, too primitive, or simply too unobservant. It's tempting to lean on these ideas because they're less bleak than the alternative. They let us imagine that we're not alone, just excluded. That somewhere out there, civilizations exist, even if they're not talking to us. But there's a catch. None of these hypotheses solve the deeper problem. They explain why we might not see or hear others, but they don't explain why we don't see any traces at all. Even if civilizations are quiet or cautious or exclusive, you'd expect at least one to slip up. One signal, one structure, one clue that we're not the only ones. The fact that we haven't found even that makes every excuse feel a little thin. It's like trying to explain why a city looks deserted by saying everyone's inside watching TV. Maybe. But after a while, the lack of any signs of life makes you wonder if the city is really populated at all. And that's the strange thing about the zoo hypothesis and its cousins. They comfort us by filling the silence with hidden company, but they also disturb us by suggesting that the company is deliberately keeping us in the dark. It's hard to decide which is worse, that we're alone or that we're being ignored. Either way, the quiet sky keeps us wondering. When we talk about life in the universe, it's easy to focus on biology. The chemistry, the planets, the water, the atmospheres. Those things matter, of course. They're the foundation. But the real heart of the mystery is intelligence. Not just the ability to survive, but the ability to think, to imagine, to invent. The fragile spark that lets a species ask questions about the stars, build tools to study them, and wonder if anyone is out there asking the same questions back. That spark feels natural to us because we live inside it. But when you step back and look at the history of life on Earth, you realize how rare, how precarious, and how fragile it really is. For most of Earth's history, intelligence of our kind simply didn't exist. Life began about 4 billion years ago. For nearly all of that time, the world belonged to microbes. They thrived in oceans, in soils, in the air. They built ecosystems, shaped the atmosphere, and evolved into countless forms. They were successful by every measure, but none of them built telescopes. None of them invented writing. None of them asked, "Where is everybody?" Life was everywhere, but minds like ours were nowhere to be found. Even when multicellular life appeared, intelligence wasn't inevitable. Dinosaurs ruled the Earth for 150 million years. They adapted to every climate, grew to massive sizes, and dominated the land. Yet, in all that time, none of them developed the kind of intelligence that builds civilizations. They had brains. Yes, they had instincts, strategies, even social behaviors, but they didn't have symbolic language or abstract reasoning. They didn't build cities or machines. And then one day, an asteroid ended their reign. All that time, all that success, gone in a geological instant, and no trace of technological intelligence to show for it. When mammals rose to prominence after the dinosaurs, intelligence still didn't appear right away. For tens of millions of years, mammals spread, diversified, and filled niches. But it was only a narrow branch, primates, that eventually produced the kind of brains capable of abstract thought. And even among primates, only one lineage developed language, art, and technology on the scale we know today. That lineage is us. Out of the countless species that have ever lived, only one has reached the point of sending machines into space. Only one has built radios powerful enough to leak into the galaxy. That's a sobering fact. It suggests that intelligence is not the natural endpoint of evolution. It's a fluke, a path that could easily not have been taken. Evolution doesn't have goals. It doesn't aim for consciousness or technology. It simply selects for traits that help survival in a given environment. For most of history, big brains weren't the winning strategy. Sharp teeth, hard shells, speed, camouflage. These worked just fine. Intelligence was expensive. Brains consume energy. Social structures require cooperation. Language requires complex adaptations. The fact that we evolved at all may be less about inevitability and more about chance. And even once intelligence appears, it remains fragile. Our ancestors were not guaranteed survival. Homo sapiens almost went extinct at least once. Genetic evidence suggests that our population dropped to perhaps just a few thousand individuals around 70,000 years ago, possibly due to climate shifts or volcanic eruptions. A few thousand. A narrow bottleneck that could easily have gone the other way. If those ancestors hadn't survived, there would be no humans today, no civilizations, no questions about the stars. Just silence as if we had never existed. That fragility continues even after intelligence takes hold. Civilizations are not permanent. History shows how easily they rise and fall. The Roman Empire expanded, thrived, and then collapsed. The Maya built great cities and then abandoned them. Ancient Mesopotamia, Egypt, Greece. Each civilization contributed knowledge, but none lasted forever. Collapse doesn't erase intelligence, but it interrupts progress. Knowledge can be lost, technologies forgotten, cultures destroyed. The fragile spark has to be nurtured continuously, or it flickers out. When you think about intelligence this way, the silence of the universe takes on another layer of meaning. Maybe there are civilizations out there, but most of them don't last long. The spark ignites, burns brightly for a while, and then goes out. Over billions of years, countless sparks could have flared and faded, leaving no lasting trace. If intelligence is fragile by nature, then perhaps we shouldn't expect to see enduring civilization spread across the stars. The silence would be the normal outcome, not the exception. This raises a troubling thought about ourselves. We imagine our intelligence as permanent, but it isn't. The spark could still go out. Nuclear war, environmental collapse, uncontrolled technologies. These are all obvious threats, but there are subtler ones too. Cultural stagnation, economic collapse, social fragmentation. If a civilization fails to preserve and pass on its knowledge, it can regress. The fragile spark doesn't just need survival. It needs continuity. And continuity is surprisingly hard to achieve. But fragility isn't the whole story. Intelligence, once it appears, has unique advantages. It allows a species to adapt more quickly than evolution alone. It allows us to cooperate, share knowledge, and build on what came before. Fire, writing, agriculture, medicine, electricity, computers. All of these were built on layers of shared memory. Each invention opened the door to another. The spark is fragile, but it's also powerful, and that's what makes it so important. If intelligence is rare in the cosmos, then protecting and sustaining it becomes not just a human responsibility, but a cosmic one. This is where the idea of the great filter loops back into our own choices. If intelligence is fragile everywhere, then maybe that's why the universe is quiet. Civilizations appear, but most of them falter. They collapse under the weight of their own fragility. If that's the case, then the silence isn't mysterious at all. It's exactly what you'd expect. But the other side of that thought is just as important. The spark doesn't have to go out. Fragility doesn't mean inevitability. It means vigilance. It means care. It means understanding how precious intelligence is and treating it with the seriousness it deserves. Sometimes when people think about alien life, they imagine advanced civilizations as inevitable. They picture galaxies buzzing with radio signals, starships crisscrossing the void, colonies on countless worlds. But the reality might be far simpler. The universe might be full of life, but the fragile spark of intelligence might almost never appear. And when it does, it might almost never last. That would make us rare. Not just rare in the sense of being unusual, but rare in a way that carries weight. Rare in a way that makes survival more than just luck. It makes it a responsibility. The silence of the universe might not mean nobody else is out there. It might mean that the ones who reach our stage don't last. It might mean that the fragile spark of intelligence is always at risk, always vulnerable, always one disaster away from being extinguished. Which leaves us with a simple but daunting question. What will we do with ours? When people imagine advanced civilizations, they often picture them as steady and enduring. A society that has mastered the stars, built wonders beyond our imagination, and spread across the galaxy sounds like something permanent, like an oak tree that will stand for centuries. But history suggests otherwise. Civilizations, even great ones, have a tendency to burn brightly and then fade. The brighter the flame, the faster it can consume itself. And when you scale that tendency up to the cosmic level, you begin to see another possible explanation for the silence in the stars. Maybe civilizations don't fail because they are weak. Maybe they fail because they are too strong, too fast, too bright for their own good. On Earth, we've seen this pattern play out in smaller ways. Ancient empires rose with astonishing energy. They conquered, expanded, innovated, and left monuments that still impress us today. But many of them collapsed within centuries. The Roman Empire at its height spanned continents, controlled trade, and set standards for governance and engineering. Yet within a few hundred years, it had fractured and faded. The Maya built great cities with advanced mathematics and astronomy, but their civilization unraveled, leaving behind ruins swallowed by the jungle. The pattern repeats across cultures and continents. Rapid growth carries seeds of instability. Resources are consumed too quickly. Inequalities widen. Conflicts escalate. Natural disasters strike. Civilizations burn bright and then vanish, leaving only fragments behind. Now imagine that pattern at the scale of a planet-wide or starfaring civilization. The more power you have, the faster you can burn through the things that sustain you. Fossil fuels on Earth were accumulated over millions of years, and within a few centuries, we've nearly exhausted them, while changing the climate in the process. Multiply that tendency across larger scales, and you can imagine civilizations elsewhere doing the same. They discover powerful energy sources, exploit them rapidly, and destabilize their environments before they learn to live sustainably. The brighter they burn, the shorter their lives. Technology itself can be part of the problem. Innovation accelerates progress, but it also accelerates risk. Nuclear weapons were developed only a few decades after the discovery of atomic structure. Artificial intelligence, gene editing, and advanced biotechnologies are arriving within a few decades of the digital revolution. Each leap brings power, but also danger. Civilizations that burn too bright may outpace their own ability to control the consequences of what they've built. They leap forward without building the cultural, ethical, or political structures to manage that leap safely. In doing so, they ignite fires they cannot put out. There's also the psychological side of brightness. Civilizations that grow rapidly may cultivate attitudes of invulnerability. Success breeds confidence, and confidence can slip into arrogance. The belief that nothing can go wrong, that growth is infinite, that problems can always be solved later. These mindsets can push societies to the brink. By the time the limits become visible, it's often too late. On Earth, we see hints of this in how slowly humanity has responded to climate change. Even though the evidence has been clear for decades, imagine a civilization with far greater powers and far greater denial. They might burn through their chance at survival before they even realize what's happening. In cosmic terms, burning too bright might also mean expanding too quickly, colonizing planets, mining stars, building massive structures. It all sounds impressive, but rapid expansion could spread a civilization thin. Supply lines, political stability, cultural unity. These things become harder to maintain as the scale grows. A sprawling galactic empire might collapse under its own weight, fragmenting into pieces that fall silent one by one. Instead of a galaxy humming with communication, you'd be left with scattered ruins of ambition, each too weak to carry the flame forward. And then there's the possibility of civilizations that consume not just their resources, but their own curiosity. A society might reach a peak where it becomes inward-looking. They might create virtual realities, so compelling that exploration no longer matters. They burn their brightest, not in expansion, but in entertainment, collapsing into digital worlds while the universe outside goes unvisited. To us, that would look like silence. To them, it would feel like triumph. But in the long run, it would mean the flame never spreads beyond their home. The metaphor of burning bright is powerful because it captures the double-edged nature of intelligence. The same qualities that allow civilizations to rise, ambition, creativity, restlessness, are the ones that can push them toward collapse. A mind that invents fire also risks burning the forest down. A society that discovers nuclear energy also discovers nuclear weapons. The flame is fragile, but it is also dangerous, and the brighter it burns, the greater the danger becomes. This might be why we see nothing in the stars. Maybe civilizations are not rare. Maybe they appear often, but they tend to flare and fade too quickly to overlap with one another. Over billions of years, sparks ignite across the galaxy, but each one burns itself out before another can catch the light. From our perspective, it looks like silence. From the universe's perspective, it might look like endless sparks, none lasting long enough to build a steady fire. For us, this idea is both a warning and a mirror. Humanity is burning bright right now. In just a few centuries, we've gone from horse-drawn carts to satellites orbiting Mars, from fire pits to nuclear reactors, from myths of the stars to telescopes that can see the edge of the observable universe. The pace is breathtaking, but it's also dangerous. Our growth has come with crises, risks, and instabilities. We are burning brighter than any species before us, but whether we can sustain it is still an open question. If the great filter is about civilizations that burn too bright, then our task is clear. We need to learn to balance brightness with endurance, to find ways of sustaining ourselves without collapsing under our own success. That means building resilience into our technologies, caution into our policies, humility into our ambitions. It means realizing that survival is not just about power, but about control. Not just about speed, but about patience. Not just about burning bright, but about burning long. The silence of the universe may be filled with the ghosts of civilizations that failed to learn this balance. If we want to be different, we'll have to confront the possibility that brightness alone isn't enough. We'll have to learn how to glow steadily, even if it means giving up the illusion of limitless growth. Because in the end, the cosmos may not reward the brightest sparks. It may only remember the ones that learn to endure. The strangest thing about the universe isn't the explosions of supernova, the swirling galaxies, or even the existence of black holes. It's the silence, the quiet that stretches across billions of light years, undisturbed by voices, by signals, by evidence that anyone else has ever been here. When you think about it, the universe should be noisy. Every calculation we've made says it should be humming with life, broadcasting itself, leaving footprints we could recognize even from afar. And yet, no matter how we look, no matter how we listen, the result is the same. Nothing but silence. This silence is not empty. It has texture, weight. Every time a telescope scans the sky and finds only natural signals, stars, pulses, quasars, dust, the silence becomes louder. Every time a radio dish listens to the heavens and hears only static, the quiet grows more unsettling. It's not the absence of evidence in a random search. It is a repeated persistent absence, like asking the same question over and over in different ways, and always hearing no reply. At some point, you stop wondering if you're re-asking the wrong question, and start wondering if there is anyone to answer at all. What makes the silence so heavy is the sheer scale of the numbers it contradicts. Hundreds of billions of stars in the Milky Way, trillions of galaxies in the observable universe, planets almost everywhere we look, chemistry that seems eager to produce complexity, time spans so vast that civilizations could have risen and spread countless times already. Against all of that abundance, the silence feels unnatural. It's like walking into a forest that should be alive with birds and insects, and instead finding it still and lifeless. Every sense tells you there should be sound, but there is none. The first time humanity pointed radio telescopes at the stars, there was optimism. Surely, we thought, if we listen long enough, we'll hear something. A pattern in the static, a signal that couldn't be natural, a cosmic hello. Decades have passed, and the optimism has dulled. We've scanned thousands of stars, listened across wide bands of frequencies, and built instruments far more sensitive than anything Fermi or Drake could have imagined. Still nothing. No clear signal. No undeniable sign that anyone else is out there. The silence persists, stretching longer with each year. Some people argue that we shouldn't be surprised. We've only sampled a fraction of the sky, a sliver of the possible signals, a tiny moment in time. The ocean is vast, and we've barely dipped in a cup. That's true. But even so, you'd think by now we might have stumbled across something. A leak of communication, a piece of technology, a structure so strange it couldn't be natural. Instead, the universe remains indifferent. Stars burn, galaxies spin, planets orbit, and the silence continues. The silence is not just absence. It's a clue. It suggests that something about our assumptions is wrong. Either life is much rarer than we think, or intelligent civilizations don't last long, or they don't behave the way we expect. Whatever the reason, the quiet sky is not neutral. It's telling us something, though we don't yet know what. There's also a psychological weight to the silence. Humans are social creatures. We're used to company, to noise, to presence. Even when we're alone, we imagine others. We tell stories, invent myths, create gods and spirits to fill the gaps. Silence makes us uneasy because it denies us that comfort. To look up at the stars and hear nothing back is to confront the possibility that we're alone on a scale far larger than we were built to handle. It's not just lonely, it's existential. And yet, silence also tempts us to fill it with imagination. That's where ideas like the zoo hypothesis or the dark forest come from. We don't like to accept nothingness, so we invent explanations. Maybe they're hiding. Maybe they're watching. Maybe they've already come and gone. Each excuse gives shape to the silence, but the silence itself remains. What's unnerving is how long it has lasted. The galaxy is billions of years old. Civilizations could have risen millions of years before us. If any one of them had spread, their presence would still be visible now. They would have left traces, energy signatures, engineering projects, something. Instead, the galaxy looks untouched. Not pristine exactly, but natural, as if intelligence never got a foothold anywhere else. That long, uninterrupted silence is hard to reconcile with the numbers that say life should be common. Sometimes people find comfort in the silence. If no one else is out there, then perhaps the universe is ours to explore. No competition, no threats, no predators lurking in the dark. But comfort quickly gives way to unease, because the same silence could mean something else entirely. It could mean that survival at our stage is nearly impossible, that others have tried and failed, and we are just the latest spark about to fade. In that interpretation, the silence is not an invitation. It's a warning. There's also the possibility that the silence isn't permanent. Maybe civilizations are rare, but not non-existent. Maybe signals are out there, but faint, fleeting, or encoded in ways we don't yet understand. The silence we experience might simply be the silence of ignorance. After all, until recently, we didn't even know exoplanets existed. Maybe the next great discovery will break the quiet. Maybe tomorrow, or next decade, or next century, we'll finally catch the whisper we've been waiting for. But we can't build our understanding on hope alone. Right now, the evidence we have is silence, and evidence matters more than wishful thinking. That's why scientists take it seriously. The silence isn't just background noise. It's the central data point of the Fermi paradox. And until we resolve it, the universe remains a riddle wrapped in quiet. For us, living in this long silence has consequences. It shapes how we think about our future. If we're alone, then our survival matters more than we can comprehend. If we're not alone, but others have fallen, then our survival still matters because we may be the only ones with a chance to endure. Either way, the silence forces us to see ourselves differently. Not just as one species among many, but potentially as the only voice in a vast and quiet cosmos. It's a heavy burden. And yet, it's also a kind of call, because silence doesn't have to last forever. One day, perhaps someone else will hear us, or we will hear them. The long silence will break. Until then, we live with it, learn from it, and wonder what it means. When people first learn about the Great Filter, the most frightening version of it isn't the past. It isn't the possibility that life is rare, or that intelligence almost never emerges. It's the possibility that the filter is still waiting ahead of us, and that right now, humanity is living in the fragile window before it arrives. That interpretation takes the silence of the universe not as a mystery, not as a coincidence, but as a warning. The galaxy is quiet, not because nobody has tried to speak, but because almost nobody has survived long enough to keep speaking. And if that's true, then our time might be shorter than we like to believe. Think about the timeline we occupy. Earth is about 4.5 billion years old. Life has existed here for nearly all of that time, and complex life for hundreds of millions of years. But humanity, the branch of life capable of building technology, of sending signals into space, has been around for barely a blink. Modern humans with language and culture for maybe a couple 100,000 years. Industrial civilization, the kind that could be detectable across interstellar distances for less than 2 centuries. That's a tiny sliver of time. If we are before the filter, then this sliver may be all we get. The troubling part is how fragile our existence looks when you step back. Our technology has given us power far beyond what our ancestors could imagine. But it has also given us tools of destruction. Nuclear weapons, bioweapons, climate change, artificial intelligence. All of these are double-edged. Each one can expand our potential. But each one also carries risks large enough to undo everything. Civilizations that live before the filter might always discover these powers. And if they handle them badly, they don't last. This could explain the silence of the universe. If the filter lies ahead, then civilizations across the galaxy may be reaching our stage, discovering the same technologies, and then collapsing soon afterward. They don't spread. They don't endure. They don't leave lasting traces. They flare briefly, burn bright, and then vanish one after another over billions of years. The result is the same quiet sky we see today. The thought is frightening because it puts us in a race we don't know we're running. If we are before the filter, then everything depends on whether we can pass it. Can we manage our technologies? Can we stabilize our environment? Can we survive our own inventions long enough to spread beyond Earth? If the answer is no, then our fate may already be sealed, no matter how much progress we've made so far. Some scientists argue that this is the most logical interpretation of the silence. After all, we know that life can appear. It did here. We know that intelligence can evolve. It did here. What we don't know is whether intelligence can survive its own power. That's the untested step. And given that the galaxy is quiet, maybe the default outcome is failure. Maybe civilizations almost always self-destruct, and we are standing at the edge of that same cliff. It's a sobering perspective, but it isn't entirely hopeless. Being aware of the filter might give us an advantage. If civilizations elsewhere failed because they never recognized the risks, maybe we can be different. We can see the dangers of nuclear war, of environmental collapse, of unregulated technology. We can study history, see the fragility of past civilizations, and try to avoid the same mistakes. Awareness might not guarantee survival, but it at least gives us chance. Still, it's hard to know if that chance is enough. The threats we face are not theoretical. Nuclear weapons still exist in stockpiles large enough to end civilization in hours. Climate change is already reshaping our planet with rising seas, shifting weather, and shrinking resources. Artificial intelligence is advancing rapidly, offering benefits, but also risks we don't yet understand. Biotechnology puts unprecedented power in the hands of small groups, and accidents or misuse could have global consequences. Each of these is a potential filter, and we are living among them right now. There's also the possibility that the filter isn't one event, but many. Not a single apocalypse, but a series of challenges. Each one capable of cutting us down if we fail to adapt. In that view, the reason the galaxy is silent is because civilizations stumble over and over again. They might survive a crisis, even two, but eventually one of the filters gets them. The fact that we're still here doesn't mean we're safe. It just means we haven't reached the last challenge yet. What makes this idea even heavier is the scale of time. If civilizations only last a few centuries or millennia before collapsing, then the odds of two existing at the same time and noticing each other are slim. From our point of view, the universe looks empty. But maybe it isn't. Maybe it's full of ghosts. Civilizations that rose, reached our level, and then fell one after another across billions of years. Their traces erased by time, their signals faded into noise. If we are before the filter, then we may be the next ghost in line. And yet, there's something strangely motivating about this possibility, too. If we are before the filter, then passing it becomes the defining test of our species. Everything else, art, science, culture, progress matters, but only if we survive. The challenge is stark, but it also gives us clarity. Our survival is not guaranteed. It has to be earned. It has to be chosen. Some thinkers suggest that the filter ahead might not be external at all, but internal. That civilizations fail not because of disasters, but because of choices. Corruption, inequality, short-term thinking, lack of cooperation. These might be the true killers. Technology and environment create risks, but it's how civilizations manage themselves that determines the outcome. If that's true, then the filter isn't about asteroids or supernova. It's about whether species like ours can grow wise fast enough to handle their own power. If we are living before the filter, then our moment is incredibly fragile. But it's also incredibly significant. Out of all the worlds in the galaxy, out of all the life that may have existed, we may be one of the few with the chance to decide whether we endure. The silence of the universe might not be destiny. It might be a challenge, waiting to see if we will be different. Of course, we don't know which interpretation is true. The filter could be behind us, ahead of us, or spread across many steps. The silence might mean doom or rarity, or simply that we are early, But we can't escape the possibility that we are still before the filter, and that everything depends on how we face it. That possibility should make us cautious. But it should also make us determined, because if the galaxy is quiet, because most civilizations do and survive, then survival itself becomes the most radical achievement we could hope for. And that's where we are now, living in the silence. Uncertain whether it's a comfort or a warning. Uncertain whether the filter is behind or ahead. But one thing is certain. If we are living before the filter, then the choices we make in this fragile moment matter more than we can possibly imagine. It's hard not to shiver at the thought that the great filter lies ahead, waiting for us. But there's another possibility, one that turns the silence of the universe into something far more flattering. Maybe the reason we don't hear anyone else is because we already made it through. Maybe the hardest barriers to life, complexity, and intelligence are behind us, and we are among the rare survivors who managed to pass. That possibility reframes the silence. Instead of being a warning, it becomes an explanation, and a strangely comforting one. The stars are quiet, not because everyone dies, but because almost no one ever gets this far in the first place. The idea begins with looking at our own story. Life appeared early on Earth, but that doesn't mean it was easy. The transition from simple chemistry to self-replicating cells is still a mystery. We don't know how many conditions had to line up, how rare the spark was. It may be that the emergence of life itself is the great filter, and that the rest of the galaxy is barren, simply because that first step is nearly impossible. If that's the case, then the silence is exactly what we should expect. Earth just happened to roll the dice and win. But even once life appears, the next steps may also be filters. Multicellularity might be so unlikely that almost no worlds ever manage it. Intelligence, as we've seen, is not inevitable. Dinosaurs thrived for millions of years without it. Perhaps the odds of a species developing language, technology, and culture are vanishingly small. If so, then the galaxy could be full of planets rich with bacteria or simple plants, but almost none with civilizations capable of wondering where everyone else is. In that case, we pass through multiple filters just to be here. There's a humbling way to think about this. Imagine billions of planets with oceans, mountains, and skies, but all of them silent. Microbes thriving under alien suns, but never inventing tools, never asking questions, never looking up. If that's the reality, then Earth is extraordinary, not just because it has life, but because it has us. The silence of the stars isn't empty. It's filled with worlds that never made it this far. We may be hearing not nothing, but the echoes of billions of near misses. If we are the survivors who passed the filter, then the weight of that realization is enormous. It would mean that intelligence capable of building civilizations is one of the rarest phenomena in the universe. It would mean that right now we might be the only ones. That sounds lonely, but it's also profoundly important. Because if there is no one else, then we are the only minds capable of carrying the torch of consciousness forward. We are the universe's experiment in awareness. And our survival isn't just about us. It is about preserving that rare spark wherever it goes. There's another interpretation, too. One that is less about biology and more about history. Maybe the great filter was not life itself, but the sequence of catastrophes Earth has already survived. The asteroid that wiped out the dinosaurs, the ice ages, the mass extinctions. Each of these events could have ended the chance for intelligence to develop here. If the asteroid 66 million years ago had missed Earth, dinosaurs might still rule, and mammals might never have risen. No humans, no civilizations, no radios. The fact that we re-hear could mean that we've already passed through a gauntlet of improbable chances, and the filter was made up of those lucky survivals. It's easy to underestimate how precarious our path has been. Human beings almost didn't make it. Our species went through bottlenecks where our population shrank to small numbers, and survival was anything but guaranteed. Entire civilizations have already collapsed in the past, and knowledge has been lost more than once. Yet somehow, the fragile thread of continuity held. Fire, agriculture, writing, science, all of it was preserved and built upon rather than erased. If the great filter is the cumulative difficulty of holding civilization together long enough to reach our stage, then perhaps we've already beaten the odds. And what a strange thought that is. That the reason the sky is quiet is because almost no one gets this far. That in all the vastness of space, we might be unique. Not because the universe is hostile, but because it is indifferent and survival is incredibly rare. It makes you want to look around at humanity with new eyes. Our flaws are obvious. Conflict, greed, short-sightedness. But our success is extraordinary too. Out of billions of planets, billions of experiments, we might be the ones who made it through the filter. This perspective is both comforting and sobering. Comforting because it suggests the worst is behind us. If the great filter was the emergence of life or intelligence or civilization, then we've already cleared it. We may still face challenges, but none that rise to the level of cosmic inevitability. Sobering because it means we carry a responsibility that few, if any others, have carried. We may be the lone survivors, the rare exception, the single voice in a universe otherwise silent. That's not just a privilege, it's a burden. Being survivors would also explain why we see no signs of others. The galaxy may not be filled with civilizations constantly rising and falling. Instead, it may be filled with worlds that never got past the filter. We look for radio signals and megastructures, but there are none because almost nobody ever reached the point of building them. If that's true, then we might be alone. Not by fate, but by sheer improbability. The silence isn't ominous. It's simply the echo of a game where almost no one wins. Of course, this interpretation doesn't remove all unease. If we have already passed the filter, then we are rare, yes, but that doesn't mean we are invulnerable. Civilizations can still collapse. We can still destroy ourselves. The difference is that collapse would not be inevitable, just tragic. We wouldn't be doomed by some universal barrier. We would simply be wasting the extraordinary chance we've already been given. So the question becomes, if we are the survivors, what do we do with that survival? Do we spread, explore, and ensure that intelligence continues across the stars? Do we protect the fragile planet that gave us life and treat our existence as the rare gift it seems to be? Or do we squander it, falling into the same traps that nearly ended us before? Passing the filter doesn't guarantee a bright future. It only means the possibility exists. This is where the silence becomes motivating. Because if we really are the rare exception, then everything we do matters more than we realize. Every scientific discovery, every act of preservation, every step towards stability and cooperation, all of it contributes to keeping the spark alive. If no one else is out there, then we are the ones who decide whether consciousness endures in the universe or not. That's a responsibility far bigger than any one nation, any one generation, or even any one millennium. And maybe that's the most powerful way to look at it. The great filter might be behind us. We may be the survivors. The silence of the stars may not be a warning, but a reminder that survival itself is extraordinary. If so, then our task isn't to fear what lies ahead, but to honor what we've already accomplished and to make sure the story doesn't end here. When we talk about the great filter, it's easy to treat it as a distant mystery, a puzzle about other civilizations, other times, other worlds. But the more you sit with it, the harder it becomes to avoid turning the question back on ourselves. Because whether the filter is behind us or ahead of us, whether we are rare survivors or just another spark waiting to go out, the truth is the same. Our own future is fragile. The silence of the universe is not just about them. It is also about us. Think about how thin our margin for survival really is. We live on a small planet with a delicate atmosphere orbiting one star in one galaxy. For billions of years, Earth has been relatively stable. But even that stability has been interrupted by mass extinctions, asteroid impacts, and ice ages. Life endured, but often at great cost. Human civilization has only existed for a few thousand years, a blink in cosmic time, and already we're pressing against the boundaries of what our world can handle. Population growth, resource use, climate change, and technology all test the limits of our resilience. Our fragility is not just external, it's also internal. Civilizations collapse not only because of asteroids or volcanoes, but because of conflict, inequality, and short-sightedness. Rome fell not just from invasion, but from overreach and corruption. The mayor didn't vanish because the stars shifted, but because their systems of agriculture and politics unraveled under pressure. History is filled with stories of societies that grew too fast, ignored warning signs, and then faltered. We are not immune to the same forces. In fact, we are more exposed than any civilization before us because the stakes are global. Now, what happens in one part of the world can ripple across the whole planet. Our systems are interconnected, fragile, and vulnerable to shocks. Technology amplifies that fragility. The same tools that give us incredible power also create risks that didn't exist before. Nuclear weapons are the clearest example. A single miscalculation could destroy cities, and a large-scale exchange could end civilization itself. Those weapons still exist. Thousands of them waiting in silos and submarines. Their presence is a reminder of how close we always are to catastrophe. And they're only one threat among many. Artificial intelligence could reshape economies, politics, and warfare in ways we don't fully understand. Biotechnology could cure diseases or create plagues. Climate change could destabilize societies before we learn to adapt. Each of these forces holds promise, but each one also carries danger. We're walking on a knife's edge, balancing between survival and collapse. And then there are the risks we can't predict. Unknown unknowns. As the saying goes, the dinosaurs didn't see the asteroid coming. Civilizations in the past didn't know what forces would bring them down. We can map probabilities, study trends, and prepare for the threats we can imagine. But the truth is, we don't know what we don't know. Some filters may be waiting for us that we haven't even considered. This is what makes the silence of the universe so heavy. It forces us to confront just how unlikely survival might be. If the galaxy is filled with planets and opportunities, and yet none of them seem to host civilizations that endured, then maybe fragility is the rule. Maybe most civilizations collapse under the weight of their own challenges, and we are living in the same precarious window. If that's true, then our future is not guaranteed. It is fragile, uncertain, and easily broken. But fragility is not the same as inevitability. To say our future is fragile is not to say it must collapse. It is to say that it requires care. A glass is fragile, but it can last for centuries if it is handled properly. A spark is fragile, but it can grow into a steady flame if it is nurtured. The same is true of civilizations. Fragility does not mean weakness. It means responsibility. So what does that responsibility look like? It begins with recognizing the risks we face and taking them seriously. It means reducing nuclear stockpiles instead of pretending they don't exist. It means addressing climate change, not with half measures, but with real effort. It means developing technologies like artificial intelligence and biotechnology with caution, oversight, and humility. It means strengthening institutions' cooperation and resilience so that shocks don't bring everything down. None of these steps are simple, and none of them guarantee safety. But together, they can tilt the odds in our favor. It also means thinking long-term. Most civilizations in history collapsed because they thought short-term. They used resources unsustainably, built systems that couldn't adapt, or ignored problems until it was too late. If we want to endure, We have to break that pattern. We have to think not in years or decades, but in centuries and millennia. That's a hard perspective for humans to adopt. But it's essential if we want to survive the fragility of our future. There's another layer too, one that is harder to measure, but just as important. Survival depends not just on systems and policies, but on culture, on values, on whether we see ourselves as stewards or as conquerors, as caretakers or as consumers. If intelligence is rare in the universe, then our role is not just to survive, but to protect the conditions that made survival possible in the first place. That means treating our world and ourselves with respect. It means cultivating wisdom alongside knowledge, restraint alongside power. This silence of the universe doesn't tell us what the future will be. It only tells us what the future has often been. Fragile, temporary, easily lost. We may be no different, or we may be the exception. We don't know. What we do know is that the future is ours to shape, and that fragility is not a reason to despair. It's a reason to be careful. It is a reminder that what we have is precious, and that the responsibility for keeping it alive falls on us. Sometimes when people talk about existential risks, it can feel overwhelming. The list of dangers is long, the odds uncertain, the stakes unimaginably high. But there is another way to see it. The very fact that we are aware of these risks is itself extraordinary. Dinosaurs didn't see the asteroid coming. Other civilizations, if they existed, may never have understood the dangers they faced. We do. We can see the knife's edge as we're walking. That awareness doesn't guarantee survival, but it gives us a chance to act. It gives us a chance to be different. So when we think about the fragility of our own future, we should hold both truths at once. That fragility is real. That survival is not guaranteed, but also that fragility is not destiny. The silence of the universe may mean others failed, but it doesn't mean we must. If intelligence is rare, then our survival matters more than we can comprehend. If intelligence is fragile, then our care must be greater than we have ever given before. And maybe that's the real lesson of the great filter. Not just that the future is uncertain, but that the future is ours to choose. Fragility is a warning, but also an invitation. An invitation to handle with care, to step lightly, but wisely, to treat the fragile spark of civilization as the rare and extraordinary thing it is. Because in the end, the silence of the universe doesn't have to be permanent. If we endure, if we spread, if we learn to balance fragility with resilience, then someday, somewhere, the silence may finally break. And if it does, it will be because we survived long enough to answer it. It's easy to hear about the great filter and feel nothing but dread. The idea that most civilizations fail, that survival might be nearly impossible, that the silence of the universe could be a graveyard of vanished sparks. It's heavy, and it should be. We're talking about the survival of intelligence itself. Not just our nation, not just our planet, but our role in the cosmos. It's no wonder the thought makes people uneasy. But hidden in that unease is something else. The fear itself points to something we often overlook. That survival is possible. That the story is not finished. And that there is hope built into the very act of worrying about our fate. The first source of hope is simply that we are here. Out of all the planets, all the odds, all the near misses, somehow life appeared, intelligence evolved, and civilization arose. That means at least once in the universe the improbable happened. That's not nothing. It's everything. It shows that filters, however real they may be, are not insurmountable. We are living proof. Even if the odds were stacked against us, they weren't absolute. This silence may mean others failed, but the fact that we're talking about it at all means success is possible. The second source of hope is awareness. Dinosaurs never worried about asteroids. Past civilizations didn't understand the forces that brought them down. We, on the other hand, can see the risks in front of us. Nuclear weapons, climate change, uncontrolled technology. We know they exist. We debate them, study them, build safeguards against them. Awareness doesn't guarantee safety, but it gives us a chance. You can't prepare for a danger you don't recognize. The very fact that we fear the filter means we are already a step ahead of those who never saw it coming. Hope also lies in the fragility we've already survived. Humanity has faced bottlenecks before. We nearly disappeared in the past when our numbers shrank to a few thousand. We endured ice ages, plagues, famines, and wars. Civilizations have collapsed, but humanity itself has persisted, learned, and rebuilt. The fragile spark has flickered, but it has not gone out. That resilience matters. It shows that even when things fall apart, recovery is possible. The silence of the universe might mean recovery is rare, but our history proves it can be done. There's another layer of hope in the very nature of intelligence. We're not locked into instinct alone. We can change course, invent solutions, and learn from mistakes. Evolution gave us the ability to look ahead, to imagine futures, to plan for problems before they arrive. That capacity is extraordinary. It means that even if the filter lies ahead, we're not powerless. We can adapt, invent, and cooperate in ways that might allow us to pass through where others failed. And then there's the hope of rarity itself. If intelligence is rare, if civilizations almost never arise, then our survival matters even more. That's not just pressure, it's purpose. It means that by enduring, by spreading, by protecting the fragile spark, we could become the exception that turns silence into song. Even if the universe is filled with failure, one success is enough to change the story. If that success is us, then our survival becomes a gift not just to ourselves, but to the cosmos. Fear then is not just paralyzing, it's clarifying. It sharpens our focus. When we fear nuclear war, we work to reduce weapons. When we fear climate change, we invent renewable energy and new ways of living. When we fear collapse, we strengthen institutions and learn cooperation. The fear of filters can motivate us to avoid them. It can make us cautious where arrogance might have destroyed us. It can give us the humility we need to endure. This balance between fear and hope is delicate, but it's real. Too much fear, and we give up, convinced that survival is impossible. Too little fear, and we become reckless, convinced that survival is guaranteed. But just enough fear tempered by the awareness of what we've already achieved can drive us forward. It can turn the silence of the stars into a challenge instead of a sentence. There's also a kind of hope in imagining that we are early. If civilizations are rare, or if conditions in the universe have only recently become suitable, then maybe the quiet sky isn't a warning but an opportunity. We may be the first to cross certain thresholds, the first to reach out into the stars. If so, then our role is not just to survive, but to pave the way for those who come after. Being early means loneliness, but it also means leadership. It means the chance to shape the pattern for all who follow. Some people even find hope in the thought that we might be alone. If we are the only intelligent species in the galaxy, then our existence is not just rare, it's unique. That uniqueness makes our survival matter more than anything else. In a universe that has produced endless stars, but only one humanity, protecting ourselves becomes the highest responsibility imaginable. It's frightening, yes, but it's also inspiring because it means that by enduring, we are preserving something irreplaceable. When you step back, you can see that fear and hope are not opposites. They are intertwined. The very things that frighten us, the fragility of intelligence, the risks of technology, the silence of the stars, are also the things that highlight how extraordinary survival would be. Hope is not found in denying the fear. It's found in recognizing that fear means the stakes are real and that the stakes are worth fighting for. In the end, the great filter is not just a theory about why the universe is quiet. It's a mirror. It reflects our fears, but it also reflects our possibilities. It shows us what could destroy us, but also what could make us extraordinary. The silence of the universe is haunting, but it is also a canvas. What we do with our fragile spark, how we face the challenges ahead, whether we become another silence or the first voice to endure, that's the story we're still writing. And fear, as heavy as it feels, is also the reason we keep writing. Because if we were doomed no matter what, there would be no point in worrying. The very fact that we worry means there is something to protect, something worth surviving for. The silence of the universe can feel like an absence, but in some ways, it's the clearest thing we have. We don't know if the great filter is behind us or ahead of us. We don't know if life is common or rare. We don't know if civilizations collapse quickly or endure for eons. But we do know this: the stars are quiet. And that quiet is not just a void. It's a signal in its own right. Like a detective who learns as much from what isn't there as from what is. We can treat the silence as a clue. It may not tell us everything, but it can teach us something. The first lesson is humility. For centuries, we assumed the universe must be full of life. Myths, philosophies, and modern science alike leaned on the idea that the cosmos was crowded. It made sense. With so many stars, so many planets, so much time, how could it not be? Yet, when we finally gained the tools to listen, we heard nothing. That emptiness is humbling. It reminds us that our assumptions are not the universe's responsibility. Just because something feels inevitable doesn't mean it is. The silence tells us to be cautious with our certainty. The second lesson is that survival is not easy. If civilizations were common and durable, we would see signs of them everywhere. Signals, structures, artifacts that lasted millions of years. The fact that we see none suggests that survival at our stage is rare. Whether the cause is biology, environment, or self-destruction, the outcome's the same. Most don't make it. That lesson matters because it applies to us directly. We can't assume we'll endure simply because we exist. Existence is not proof of permanence. The silence is evidence that survival is fragile. But there's also a third lesson, one that is strangely empowering. If we don't see anyone else, then the responsibility falls to us. Whether or not others exist, whether or not they survived, our choices now matter enormously. The silence highlights the value of our survival. It says, if intelligence is rare, then yours may be the only voice in the dark. That turns survival from an instinct into a purpose. We don't just live for ourselves. We live for the possibility that intelligence, awareness, and meaning continue to exist in the universe. The silence also teaches us about perspective. It's easy to feel overwhelmed by the idea of being alone or by the risks we face. But the quiet sky forces us to zoom out, to recognize that we're part of a bigger picture. Civilizations may be fragile, but so are stars, planets, galaxies themselves. Nothing lasts forever. In that sense, our fragility isn't unique. It's universal. And if everything is temporary, then the meaning of survival isn't eternity. It's endurance long enough to matter, to create, to leave something behind. The silence reminds us that even in a transient universe, value exists. Another lesson from the silence is the importance of cooperation. If survival is rare, then division only makes it harder. The risks we face, nuclear war, climate change, technological misuse, are global. They can't be solved by one nation, one ideology, one faction. They require cooperation at a scale we've never consistently achieved. The silence shows us what happens if civilizations don't cooperate. They vanish. Whether others failed because of war, collapse, or isolation, the outcome was the same. If we want to avoid joining them, we have to learn to work together. The silence in that sense is not just a mystery. It's a warning label. There's also a quieter lesson, one that is less about risk and more about gratitude. The silence means we may be rare, perhaps uniquely so. If that's true, then every moment of our existence is extraordinary. Every sunrise, every act of kindness, every discovery, every laugh, every question asked under the stars, all of it is part of something the universe almost never produces. Intelligence is not ordinary. Awareness is not ordinary. We are not ordinary. The silence invites us to stop taking our existence for granted. At the same time, silence can also teach us patience. We may simply not have listened long enough, or in the right ways. The universe is vast, signals are faint, and our tools are young. The quiet may not mean absence. It may mean we need to keep trying. That lesson applies beyond the search for extraterrestrial life. It applies to survival itself. Progress takes time. Change takes patience. The silence reminds us that just because we haven't succeeded, it doesn't mean success is impossible. Finally, the silence teaches us about meaning. For centuries, we've wondered if we are alone. We've tied our sense of importance to the presence of others. If we are not alone, we are one among many. If we are alone, we are unique. The silence refuses to resolve that question. It leaves us suspended in uncertainty. And maybe that's the greatest lesson of all. Meaning doesn't depend on what the universe does or doesn't contain. Meaning is what we create here together with the fragile spark we've been given. The silence of the universe is not comforting, but it isn't empty either. It teaches humility, caution, cooperation, gratitude, patience, and meaning. It reminds us of fragility, but also of possibility. It warns us, but it also motivates us. The universe may be quiet, but that doesn't mean it has nothing to say. We just have to learn to listen, not only to the stars, but to ourselves. When we think about the great filter, it's easy to drift into the vastness of space. We imagine distant civilizations, long timelines, cosmic challenges that stretch beyond our comprehension. But sometimes the most important part of the puzzle isn't out there. It's here on this small blue planet that we call home. Because no matter what the silence means, no matter whether the filter is behind us, ahead of us, or somewhere in between, one truth remains. Everything we have depends on Earth. Holding on to it is the first and most important step in holding on to ourselves. Look at Earth from space. The way astronauts describe it, a fragile ball wrapped in a thin atmosphere, glowing with oceans and clouds alone against the black. That perspective strips away the illusion of endlessness. From the ground, resources can feel infinite. Skies seem boundless, forests vast, seas eternal. From orbit, you see the truth. It's small, finite, and vulnerable. The systems that keep us alive, air, water, soil, climate, are delicate, balanced, and easily disrupted. We've built a civilization of billions on top of those systems, but we don't control them, we depend on them. That dependence makes our situation both humbling and urgent. If we are one of the rare survivors of the Great Filter, then this planet is not just our home. It's the cradle of intelligence in the galaxy. Maybe the only one. If intelligence is fragile, then Earth is the only place so far that has nurtured it. That makes every river, every tree, every patch of soil more valuable than we can measure. They are not just natural features. They are the foundation of the only known civilization in the universe. And yet, our relationship with Earth has always been complicated. For most of human history, we treated it as infinite. We hunted, farmed, cut, earned, and mined without worrying about limits. The planet seemed to absorb everything we did. But now, on a scale never seen before, we are testing those limits. We burn fuels that heat the climate. We cut forests that stabilize the weather. We pollute oceans that feed billions. We deplete soils that took millennia to form. For the first time, our actions are not just local, they are planetary. We have become a geological force, changing the Earth itself. This is where the Great Filter ties directly into our future. Because one possible filter is exactly this, the failure to live sustainably on a home planet. Civilizations might rise, flourish, and then collapse when their environment can no longer support them. On Earth, we see that pattern in miniature. Societies that overfarmed, deforested, or mismanaged resources often collapsed. The difference now is scale. In the past, collapse meant a region or a culture. Today, collapse could mean the entire planet. That reality makes holding on to Earth more than just an environmental issue. It's a survival issue. It's a cosmic issue. If the silence of the universe means most civilizations destroy themselves by failing to protect their planets, then our task is clear. Don't repeat the mistake. Learn to live within limits. Learn to sustain the systems that sustain us. Learn to treat this small planet not as a resource to consume, but as a partner to nurture. Of course, that's easier said than done. Humanity is complex, divided, and driven by competing needs and desires. Change is hard, especially when it challenges habits of comfort and growth. But history shows that we can adapt when we must. We've faced crises before, plagues, wars, famines, and we've survived. The challenge now is to recognize that our survival depends not on conquering each other, but on caring for the fragile world that holds us all. It helps to remember just how rare Earth may be. Astronomers have found thousands of exoplanets, and many may be habitable, but habitable doesn't mean inhabited. And inhabited doesn't mean intelligent. We don't know if there's another Earth out there, and we can't assume there is. Right now, this is the only world where rivers flow, birds sing, and humans walk. Until we find another, or build the means to create one, Earth is our only chance. That should change how we treat it. There's also a psychological challenge here. It's tempting to dream about leaving, to think that space colonization will solve our problems, that Mars or other planets will become new homes. And maybe one day they will. But the truth is that even the most advanced colony will depend on Earth for centuries. Mars is harsh, space is hostile. The only place where life thrives naturally is here. That doesn't mean we shouldn't explore, but it does mean we can't treat Earth as disposable. There is no backup ready, no second chance waiting. If we lose this world, we may lose everything. Holding on to our small planet also means rethinking what progress means. For centuries, progress has been measured in growth. More people, more consumption, more power. But growth without balance is unsustainable. A civilization that burns too bright, as we've seen, risks burning out. Progress in the future may need to be measured differently in resilience, in sustainability, in the ability to endure rather than just expand. That's not as flashy, but it's more important because endurance is the only way to outlast the silence of the stars. There's a deeper lesson here, too. One that goes beyond survival. Holding on to Earth isn't just about avoiding collapse. It's about appreciating what we have. If we are rare, then every forest is extraordinary. Every ocean wave, every animal, every culture, every song sung under the night sky, all of it is part of something unique in the cosmos. The silence of the universe doesn't diminish that. It magnifies it. The quieter the stars, the more precious Earth becomes. So when we talk about the Great Filter, we shouldn't just think of distant civilizations or abstract probabilities. We should think of our rivers, our air, our climate, our communities. We should think of how fragile they are and how much depends on protecting them. The silence is not just a puzzle. It's a reminder. If we want to endure, if we want to be different, if we want to be the exception, then we have to hold on to our small planet. Not for a decade, not for a century, but for as long as the spark of intelligence can last. And maybe that's the most hopeful way to see it. Silence doesn't have to mean doom. It can mean opportunity. A reminder that we are one of the few, maybe the only who has made it this far. A reminder that our world is precious beyond measure. A reminder that survival isn't about grand gestures, but about care for each other and for the only planet that has ever carried us. Because if the great filter has already ended countless civilizations, if the silence is the sound of their absence, then perhaps the simplest and most radical act we can commit is to endure to take care of Earth, to make sure the fragile systems that cradle us stay strong. To remember that holding on to this small planet is not just survival, but resistance against the silence itself. The great filter is one of those ideas that doesn't let go once you've heard it. It follows you quietly in the background whenever you look at the stars or think about the future. 'Cause it isn't just about aliens or numbers or distant galaxies. It's about us, about how fragile our place is, how rare it may be, and how much hangs on the choices we make. Whether the silence of the universe is a warning, a comfort, or a mystery, it points back here to a small blue planet where one species, for reasons we still don't fully understand, has become aware enough to ask these questions. And maybe that's where the hope lies. Not in having all the answers, but in the act of asking. The great filter forces us to confront the possibility of our own limits. But it also highlights our capacity to reflect, to wonder, to imagine futures that don't yet exist. That capacity is part of what makes intelligence precious. Even if we are rare, even if we are alone, we have the ability to look ahead, to weigh risks, to dream about survival, and to change course when needed. That isn't nothing. That's everything. Think of how far we've come already. For most of history, the stars were lights without meaning, scattered across the night. Then we built stories around them, constellations that told us who we were. Later, we learned they were suns, each with their own planets, each with their own possibilities. Now, we've built machines that can look across billions of light years, and still the silence remains. But that silence no longer feels empty. It feels like a reminder that intelligence is fragile, that survival is uncertain, and that if the universe is quiet, maybe we are the ones who will have to speak first. A gentle farewell across the stars doesn't mean resignation. It doesn't mean giving up. It means acknowledging the scale of what we face and choosing to carry our spark carefully anyway. It means remembering that our survival is not guaranteed, but neither is our failure. The silence of the universe may be long, but it is not final. Not yet. The story isn't finished. We are still writing it. And so, the farewell here isn't to you, the listener, or even to the series of questions we've walked through together. The farewell is to the idea of certainty, to the comforting illusions that survival is inevitable, or that intelligence will always endure. Letting go of those illusions is what makes the great filter so unsettling. But letting go is also what gives us clarity. We see the risks for what they are. We see the fragility of our world. We see the extraordinary rarity of being here at all. And once you see that, you can't unsee it. You can only decide what to do with it. That's where the personal part comes in. These questions are cosmic, yes, but they're also intimate. They touch how we live, how we treat one another, how we think about our future. They remind us that survival doesn't just depend on technology or policy. It depends on care, on empathy, on cooperation, on the recognition that we are all passengers on the same small planet, fragile in the same ways, tied to the same fate. Holding on to that perspective is part of holding on to the spark itself. So here we are drifting at the edge of what we know, looking out into the quiet and wondering what it means. Maybe the great filter is behind us. Maybe it's ahead. Maybe we are early. Maybe we're alone. We don't know. But the silence doesn't mean nothing. It means responsibility. It means that what we do here on this small planet matters more than we can imagine. And that thought, while heavy, can also be comforting, because it means that the choices we make, the care we show, the risks we avoid, the hope we nurture, may be the very things that decide whether the silence lasts forever or whether one day it will finally break. And now, as we close this journey together, I want to bring the lens back to you. Where are you listening from tonight? Are you lying in bed, the lights dim, headphones in, drifting toward sleep? Are you on a quiet walk, looking up at the stars between streetlights? Are you in a busy place, carving out a little pocket of calm to sit with these thoughts? Wherever you are, thank you for sharing this stretch of time. Thank you for letting your curiosity wander here into questions that may not have answers, but still matter. Because it's in the asking, in the wondering, that hope begins. If you found comfort here, if you found curiosity stirred, I'd be grateful if you left a like or subscribed. It helps this quiet corner of the internet reach others who may need it. But more than that, I hope you carry the thought with you that we are fragile, that we may be rare, and that this makes us precious, that survival is not inevitable, but possible. And that possibility is enough to keep going. So let this be a gentle farewell, not final, not absolute, but a pause, a farewell across the stars, where the silence still waits, and where one small voice of our own continues to speak. The story isn't over. It has only just begun.